This is Tech and Politics, and my name is Andreas Jungherr. Welcome back to the podcast accompanying the lecture series Digital Media and Politics and Society at the University of Bamberg. In this and the following episodes, we will be talking about artificial intelligence and its impact on politics. Picture this scene. An astronaut floats in the vast nothingness of space. Only the thin walls of his maintenance pod protect him from a certain and cold death in space. His survival depends on him being able to convince HAL, the board computer of his ship, to let him back on board. The astronaut Dave says, "Open the pod bay doors, HAL." The computer HAL answers, "I'm sorry, Dave. I'm afraid I can't do that." The astronaut asks, "What's the problem?" The computer answers, "I think you know what the problem is just as well as I do." "What are you talking about, HAL?" "This mission is too important for me to allow you to jeopardize it." "I don't know what you're talking about, HAL." "I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen." This iconic dialogue comes from 2001: A Space Odyssey, the 1968 movie directed by Stanley Kubrick, written by Stanley Kubrick and the science fiction author Arthur C. Clarke. For better or worse, the image of the psychotic computer HAL threatening to kill the very humans he was tasked with supporting in order to achieve what he has calculated to be better chances of achieving their shared mission has shaped the popular representation of artificial intelligence ever since. Be it Marvin, the paranoid android in Douglas Adams' The Hitchhiker's Guide Through the Galaxy, an Arnold Schwarzenegger-shaped T-800 in James Cameron's Terminator movies, or Battlestar Galactica's Cylons. HAL's descendants share his strained relationship with humanity. No wonder we are used to thinking about artificial intelligence as a threat or a source of uncontrollable danger. The existential doubts of Blade Runner Rick Deckard, the attempts at trying to understand humans by Star Trek's Lieutenant Commander Data, and the search for love and connection of two lost humanoid robots in Steven Spielberg's movie AI provide a different but just as warped picture of AI. Here, we do not necessarily encounter a threat in AI, but the search for supposedly soulless machines for a meaning to life. Ultimately, in encountering these AI, the lines between artificial and human intelligence and life begin to blur. We find us looking into a silicon mirror. AI either as a threat of a cognitively and physically superior entity to us humans, or as a silicon-based life form striving to similar status of human intelligence and meaning. These tropes not only shape popular culture, but also our expectation of AI's effects on society. Public luminaries like Stephen Hawking or Bill Gates warn us from the danger of AI, while futurists promise an end to the tyranny of our decaying flesh by our minds melding with machines. This makes for stimulating reading and is the stuff of countless think pieces. While it is easy to shrug at these concerns as overexcited science fiction, artificial intelligence is a vibrant field of academic research and commercial enterprise. We encounter AIs daily, be it in the voice assistants in our homes and phones, through automation in our workplace, or as the drivers of policing and credit decisions. AI is a largely invisible feature of our daily lives, with clear consequences for us as citizens and consumers. But these consequences are more difficult to interrogate than watching the T-800 violently tear through a city. Still, examining the workings and real-world consequences of actually existing artificial intelligence is important. This is what we'll do in this and the following episodes. In our discussion, we focus on the impact of AI on democracy. To do so, we first start with the discussion of what artificial intelligence is and is not. These days, everybody seems to be talking about artificial intelligence, or AI for short. At the same time, expectations diverge widely. Some say AI is the basis for future economic growth and a boon for human well-being. Already in 2002, the futurist, Singularity Booster, and later Google's director of engineering, Ray Kurzweil, publicly bet for, and I quote, AI to surpass native human intelligence, end quote, by 2029. The business and management professors Eric Bjornson and Andrew McAfee expect that, and I quote, in the sphere of business, AI is poised to have a transformational impact on the scale of earlier general-purpose technologies. The effects of AI will be magnified in the coming decade as manufacturing, retailing, transportation, finance, healthcare, law, advertising, insurance, entertainment, education, and virtually every other industry transform their core processes and business models to take advantage of machine learning. End quote. Others see AI as a potentially existential threat to human life as we know it. For example, Tesla founder and serial entrepreneur Elon Musk speculates about AI being, and I quote, our biggest existential threat, end quote, and likes it to, and I quote, summoning the demon, end quote. Apparently, the physicist and public intellectual Stephen Hawking shared these fears when he said, and I quote, we cannot know if we will be infinitely helped by AI or ignored by it and sidelined, or conceivably destroyed by it, end quote. Bridging the gap between these two poles, Microsoft co-founder Bill Gates publicly speaks of AI as, and I quote, both promising and dangerous, end quote, likening it to nuclear weapons and nuclear energy. Of course, exactly how much of a relief this comparison provides probably varies among listeners. What is it about AI that leads to these strong and widely diverging opinions? To answer this question, let's start by figuring out what exactly the term artificial intelligence means. In his history of the research field, Niels J. Nielsen defines artificial intelligence as, and I quote, that activity devoted to making machines intelligent. And intelligence is that quality that enables an entity to function appropriately and with foresight in its environment, end quote. This definition provides a broad tent for scientific, engineering, and commercial endeavors affiliated with making intelligent machines or learning about intelligence through machines. The continued scientific quest for artificial intelligence starts roughly in the 1950s, bringing psychologists, engineers, and computer scientists together. These efforts begin as the attempt at understanding human intelligence better by trying to recreate it in machines, while at the same time getting machines to perform tasks traditionally assigned to humans, such as playing board games. In the early days of the field, from the 1950s to the 1990s, scientific and commercial efforts in artificial intelligence were dominated by knowledge-based approaches, trying to teach machines about the world, be it the meaning of words, grammar, or expert knowledge in specific subfields. Approaches like this started out being highly popular among scientists and funders, but lost steam when the promised results failed to materialize. The associated frustrations and decreased scientific interest and funding opportunities have become known as AI winter. But each winter ends with the onset of spring. The first signs of the onsetting AI spring appeared in the 1990s. Increased computing power and ever-growing availability of large datasets documenting ever more aspects of human life and society in the context of the digital transformation led to growing interest in the uses of neural network models. Neural networks are a family of computational models that is inspired by the workings of the human brain. In a very simplified account, the brain consists of networks of interconnected neurons. Each neuron receives stimuli. Once these incoming stimuli pass a certain threshold, a neuron sends out an electrical signal that itself serves as an input to other connected neurons. This model of the brain concentrates on its information processing characteristics, in which interconnected neurons accept and process information, and through their interconnections are able to achieve stunning feats of translating information into perception, knowledge, or action. Artificial neural networks follow the same logic in their architecture and functioning. Artificial neurons accept numerical inputs and translate them into a single output variable. These artificial neurons are arranged in networks with varying levels of network layers. A first input layer accepts unprocessed signals and puts them through to a series of so-called hidden layers. These hidden layers accept the outputs of the network layer above them, process these outputs, and transmit them to a further layer until a final output layer is reached that provides the result of the model. This structure allows neural networks to, and I quote, identify and extract patterns from large datasets that accurately map from sets of complex inputs to good decision outcomes. End quote. Kelleher, 2019. This process is called deep learning and enables machines to make data-driven decisions. Deep learning has made machines highly efficient in automated pattern recognition and decision-making without relying on knowledge or theory. This purely data-driven approach to artificial intelligence has produced spectacular results, allowing machines to beat humans at board games, such as chess or Go, to automatically translate text from one language into another, as with Google Translate, recognizing spoken language, as with automated voice assistants like Alexa or Siri, or being able to recognize objects in images, a crucial task for self-driving cars. In fact, deep learning and its commercial applications have been so successful that deep learning has nearly grown synonymous with artificial intelligence, thereby reducing the field's richness and varied heritage to a limited set of data-driven models and approaches. It is no surprise, then, to find voices growing in volume that ask, are purely data-driven approaches in artificial intelligence really intelligent? At least in any meaningful sense of the word. Let's go back to Nielsen's definition of AI. And I quote, "Artificial intelligence is that activity devoted to making machines intelligent. And intelligence is that quality that enables an entity to function appropriately and with foresight in its environment." End quote. As discussed, this definition is very useful, since it covers different aspects and goals of artificial intelligence research and development. At the same time, the definition also points to an inherent tension within the field. For example, what accounts for, and I quote, functioning appropriately, end quote? What counts as foresight? And, perhaps most controversially, what is the minimum requirement to meaningfully speak of function in its environment? Nielsen consciously takes a liberal approach to these questions. And I quote, "According to that definition, lots of things, humans, animals, and some machines, are intelligent. Machines, such as smart cameras, and many animals are at the primitive end of the extended continuum along which entities with various degrees of intelligence are arrayed. At the other end are humans, who are able to reason, achieve goals, understand and generate language, perceive and respond to sensory inputs, prove mathematical theorems, play challenging games, synthesize and summarize information, create art and music, and even write histories." End quote. This approach works well for charting the development of the field of artificial intelligence and covering its varied points of origin and developmental paths. But in order to understand the larger societal effects of artificial intelligence, it is limiting, if not misleading. Such a broad account of what it means to be intelligent allows commentators to conflate highly specific feats of data-driven pattern recognition and decision-making with more general and substantively different expressions of intelligence, such as creativity, embodied knowledge, or abduction. Impressive but highly specific feats of data-driven prediction and decision-making, such as winning against humans in board games like chess or Go, are used to infer the subsequent replacement of human decision-making in other contexts. This is a category error. By using undeniable and impressive progress of machines in one narrow category of intelligence, pattern recognition and decision-making based on the automated analysis of large datasets, with another broader general intelligence. This surprisingly popular fallacy gives rise to what Eric Larson calls the myth of artificial intelligence. And I quote, "The myth of artificial intelligence is that its arrival is inevitable and only a matter of time. That we have already embarked on the path that will lead to human-level AI and then superintelligence." End quote. This myth is dangerous, since it ignores the crucial differences between the type of intelligence found in current AI-empowered systems and a human-level general intelligence. And I quote, "The myth of AI insists that the differences are only temporary and that more powerful systems will eventually erase them. The myth assumes that we need only keep chipping away at the challenge of general intelligence by making progress on narrow feats of intelligence, like playing games or recognizing images. This is a profound mistake. Success on narrow applications gets us not one step closer to general intelligence. As we successfully apply simpler, narrow versions of intelligence that benefit from faster computer and lots of data, we're not making incremental progress, but rather picking low-hanging fruit. The jump to general, common sense is completely different, and there's no known path from one to the other." End quote. This error of using evidence of successful applications of artificial intelligence for specific, narrowly defined tasks to project the imminent emergence of a general artificial intelligence that will be replacing human decision-making in all walks of life matters especially in the discussion of the expected societal effects of artificial intelligence. Jumping from, "Wow, Alexa automatically ordered fresh yogurt because the fridge told her my supplies were running low," to, "A Skynet-level artificial intelligence is about to emerge and threatens to end life on Earth." This is a category error and logical fallacy. This does not mean that artificial intelligence has not made great strides, and in turn made philosophers and cognitive scientists rethink crucial tenets of what exactly constitutes intelligence. But by conflating the two different categories of intelligence, we run the risk of misdiagnosing the nature, impact, and trajectory of artificial intelligence. One way to account for these differences is to differentiate between narrow artificial intelligence and artificial general intelligence, AGI. Narrow AI refers to systems developed for a specific, singular, or limited task. Examples for this include AlphaGo, an artificial intelligence highly adept at playing the board game Go, and only the board game Go. While AlphaGo is staggeringly successful in beating even the most adept of human players at Go, it would be useless at playing checkers. Of course, one could develop a program dedicated to dominating the world of competitive checkers players using the architecture and logic behind AlphaGo, but this would be a new artificial intelligence only dedicated to this one task. In contrast, an artificial general intelligence would be a machine with the same cognitive and intellectual capacities as a typical human. For example, it would be able to hold a conversation in natural language, solve problems in different areas, perceive the world and its position in it, and reason about it. While the public imagination focuses on AGI, scientific research and commercial applications nearly exclusively focus on narrow AI. Computer scientists might chafe at the term narrow AI, as it characterizes what most people and programmers in the field of artificial intelligence actually do. In the words of Michael Woolbridge, and I quote, "We don't refer to what we do as narrow AI, because narrow AI is AI." End quote. Still, both terms help us to keep in mind the difference between what we imagine AI can do and what it actually does. The importance of this difference starts to feature strongly in the public discussion of artificial intelligence and its applications in society. For example, with Rebooting AI, the psychologist Gary Marcus and the computer scientist Ernest Davis has offered a highly influential critique for the general reader of the uses of narrow AI for tasks that demand for understanding and reasoning. While critical about the current purely data-driven state of artificial intelligence practice, they remain optimistic about the possibility to develop AI systems that incorporate understanding and that can be critically interrogated and evaluated regarding the foundations of their decisions and their outcomes. The computer scientist and philosopher Brian Cantwell Smith is less optimistic about the eventual emergence of an AI with true understanding. In The Promise of Artificial Intelligence, he emphasizes the difference between two intelligence tasks, reckoning and judgment. With reckoning, he refers to calculation tasks current instances of AI are highly successful at, like those discussed above. And I quote, "The representation, manipulation, and other forms of intentionally and semantically interpretable behavior carried out by systems that are not themselves capable of understanding what it is that those representations are about, that are not themselves capable of holding the content of their representation to account, that do not authentically engage with the world's being the way in which their representations represent it as being. Reckoning is a term for the calculative rationality of which present-day computers are capable." End quote. In contrast, Smith uses the term judgment for the sort of understanding, and I quote, "that is capable of taking objects to be objects, that knows the difference between appearance and reality, that is existentially committed to its own existence and to the integrity of the world as world, that is beholden to objects and bound by them, that differs and all the rest." End quote. This difference between these forms of intelligence is not just a matter of terminology or purely academic interest. Instead, by employing machines adept at reckoning for tasks that require judgment, societies risk having machines calculate and initiate decisions based on the representation of the world and not the world itself, and without any commitment to the consequences of these decisions. Conversely, by focusing on the staggering successes of machines with reckoning tasks, might lead over time to devaluation of judgment, tasks that machines are not successful at, thereby settling on a critically reduced account of what human intelligence is and should be about. Keeping the difference between reckoning and judgment in mind is therefore crucial in the discussion of what artificial intelligence can do and for what tasks it is employed. Smith's book might be less accessible to the general reader and does not feature broadly in the public discussion about AI. Still, it is a very nuanced discussion about the nature of intelligence, being in the world, and the uses of artificial intelligence. In this, it reinforces earlier efforts in which artificial intelligence served as an approach to better understand the workings of the brain and human intelligence. For the discussion of the impact of artificial intelligence on democracy, it is therefore important to be precise about what kind of artificial intelligence we are talking. While it is easy to extrapolate far-reaching impacts of an imagined artificial intelligence on aspects of democracy, this is probably not the best use of our time. Instead, we will focus on the impact of aspects of artificial intelligence already in evidence, the power of data-driven prediction of outcomes of interests, and the impact of this on specific aspects of democracy. Well, after clearing up what we mean by artificial intelligence, let's close for now. In the next episode, we will have a closer look at how artificial intelligence looks in practice. As always, the script to this episode can be found online come Thursday on the course website, digitalmedia.andreasjungherr.de. There, you will find detailed sources, references to further reading, and preparatory questions for the exam. This was Tech and Politics, the podcast of the Chair for the Governance of Complex and Innovative Technological Systems at the University of Bamberg. I'm Andreas Jungherr. Have fun reading, and see you soon.